Hello and welcome all to my YouTube channel. Basically, this YouTube channel is created to cover most of the protocols. That's the main agenda in a layman terms, which would be easy for you to understand as well as debug. So, starting with first, we would be covering the network protocol, which is nothing else but DHCP. DHCP is basically dynamic host configuration protocol. So basically each and every device which is present in the network requires an IP address. The IP address can be either static or dynamic. To assign a static IP address, there are two ways. Either you can assign it manually by logging into the local UI of that particular device and assigning it the IP address, the subnet mask and the gateway. The second option is MAC address binding. MAC address binding is the physical address of the device. MAC stands for medium access control, which is nothing but it is a unique identifier assigned to each of the device. It is basically a 6 byte network identifier and it is unique worldwide. That means no two devices in the world would be having the same MAC address. So in case of MAC binding at the router level, you would be reserving some network host. So basically MAC address and a IP address would be binded and stored in the router. So whenever the device comes up in the network, in that case, that particular IP address would be assigned to that particular MAC address. So this is nothing but assigning of static IP. The second one is the DHCP, which we would be concentrating in this particular session. So basically, whenever a new device is plugged or new host is plugged, it doesn't have any IP address. So host doesn't know what is the source address to use. Okay, host doesn't know who to ask for an IP address. So in that case, basically, host discovers. Okay, basically host sends a broadcast packet. Okay, which is nothing but a discover packet. Okay, it basically shouts in the network that who can help me with that, with a particular IP address, or who can give me the IP address. So generally this is a broadcast request sent at the physical layer. Okay, and broadcast is basically a service discovery message, layer 2 message. Server sends a reply offering a address. Basically a DHCP works on a client server architecture, we can say. So the device which is requesting the IP address is nothing but a DHCP client. The device which is serving the DHCP request is the DHCP server. As discussed earlier, DHCP stands for Dynamic Host Configuration Protocol. Okay, yeah, so this is the new client and it is a DHCP server. DHCP server is generally in the network at the router level, or a specific, we can say a machine is configured as a DHCP server. So DHCP basically works on the DORA logic, that is the discover, offer, request, acknowledge. Okay, so whenever a new client is plugged into the network, it broadcasts a message saying that yeah, I'm in the network and please provide me the IP address. DHCP server receives that particular request. It captures the MAC address and assigns a IP address to that particular device. Basically offers it. Okay, once that particular IP address is received, then the client basically acknowledges, requests the DHCP server to give that particular IP address. And if during this handshake, if the DHCP server did not receive any other request from any other clients, it can basically acknowledge that yes, you can use this particular uh, IP address, and that's it. The handshake is done. Okay. So generally, this process is called the DORA process: discover, offer, request, and acknowledge. Then we have a tool called as Wireshark, basically, which is used to capture the packets in the network. Okay. Do remember, Wireshark can be executed on any particular machine. If you want to capture the packets or the communication between point-to-point communication, say between your device and say the router, Okay, so in that case, you need to run a TCP dump at the router end. Or if you have a communication between your device and your laptop, so in that case, you can run the Wireshark packets on your laptop. Okay, but if you want to basically basically, if you're running Wireshark anywhere in the network, all the broadcast requests will be captured. So in this case, basically the offer request is a broadcast request, and the request message is also a broadcast request. So basically, these two requests would be captured in the Wireshark. You can easily download the Wireshark by Google. Okay, just you can download the Wireshark as per your operating system. Maybe it could be a Windows or Mac OS or a Linux one. The installation process is similar to all other softwares. If required, I'll create a special video related to installation process. Doing a if config all, okay, basically you can check whether your machine is DHCP enabled or not, what is the IP address, what is the MAC address, and all these things. Okay, yeah, this is the filter which can be used to filter out the DHCP request. Okay, as you can see, the eth.addr is nothing but the filter used to capture the MAC address of the device. The 000E is the MAC address of the device. Please note the format in which it needs to be entered. Double ampersand sign is used to denote or used to basically it is a AND type of. So basically it will check for the MAC address as well as the DHCP protocol. Okay, and there is one more, basically the BootP protocol. Basically DHCP works on the BootP protocol. So basically if you want to capture the DHCP packets directly, you can just input the BootP and all the DHCP packets in the network would be displayed. If you want to check for a specific MAC address, then you can use the ampersand sign. Here basically we need to select the Ethernet adapter also. Okay, so basically whether it is on a Ethernet or a Wi-Fi or on some other port, okay, that could be the possibility. Once selected, you can click on the start. Yeah, so basically these are the packets: discover, offer, request, acknowledge. Okay, so as I told you, initially it doesn't have any IP address. So basically the request is gone using at the MAC layer, and the IP address is displayed as 0.0.0.0.0. And as you can see, 255.255.255.255 is the broadcast IP address. Okay, so all devices or hosts present in the network would be receiving this particular packet. This is nothing but the discover packet. Then the router basically sends the offer packet. It basically offers a particular IP address along with a lease time. Lease time is nothing but for how much time this particular IP address should be used. Okay, that is defined over here. Once that particular lease interval is finished, okay, that particular IP address would be assigned to another user. Okay, so that is the case. So say suppose lease time is of 1 hour. So in that case, the IP address would be assigned for 1 hour. After 1 hour, say still if the device is not in the network, so I mean the device went offline, the device is powered off. After 1 hour, the IP address would be assigned to some other device. Okay, and the next one is suppose that particular device wants the same IP address. Then after the half interval of lease time, that particular device needs to send a lease renewal request. Only after the lease renewal request is accepted, then only the device will get the same IP address, else it will get a different IP address. Okay. Yeah, DHCP protocol does have a risk of getting attacked by an intruder. So local intruder can capture these broadcast packets and sniff this offer packets, and he would be able to know for how many times this particular device would be using the IP address. We'll cover in the next section how we can tackle this particular issues. Okay, meet you soon. Thank you.